start on the day's work. Are there any questions over the homework? Questions over the homework assignments? Which one? Anyone in particular? I'm going to look at 56 because I think you're understanding how to do it. It's just
Did I do it wrong?
signs would be. Yeah. Yeah. So 56. And it might line up. We'll see. So 56, it's asking for a few things. It wants the vertex, axis of symmetry, and the x-intercepts. Now to find any of that, we'll need the values of P and Q. So what would our values of P and Q be here? 5 and 1. Now they're not negative because the general form is x minus P, x minus Q. So technically, since we do already have the minus in the equation, P and Q are both positive. Kind of, we see that distinction. So it's one of the places where we normally see an error. So P and Q are this here. For the vertex, I need to calculate P plus Q over 2. So for us here, we'd have 5 plus 1 over 2. Now we can do this by hand, we can do it in the calculator. Well, 5 plus 1 over 2 is 3. And the other part of this, because that gives us the vertex, half the vertex, because the vertex is P plus Q over 2, comma F of P plus Q over 2. We just take that value and plug it back in. So we have 2 times 3 minus 5 times 3 minus 1. And again, at this point, we can type it into the calculator or do it by hand. 2 times 3 minus 5. Be helpful if I actually type 5. Parentheses, 3 minus 1 is negative 8. So that means our vertex is the point 3, negative 8. Axis of symmetry. Almost.
Oh yeah, I forgot you have to do that one.
Yes? There we go. Because axis of symmetry is always going to be x equals or y equals. We need an equation for axis of symmetry. Now, x-intercepts. P comma 0 and Q comma 0. 5, 0, 1, 0. So that would be the whole equation or whole answer is all that there. So I think you see what I was saying with signs. Yep, that's it. So I'd look at the other two and make sure your signs are right. I think one of them is, the other's not. Questions on this here? Any other questions on the? Any other questions over the homework? All right. What we're looking at today is more parabolas. I think you need the homework sheet. So these are the general forms. Yeah. I did make a correction or change this year to it, and I forgot to make the change on the sheets, but it doesn't make a huge difference because A, the number in front of the parentheses is 1 over 4p. 1 over 4 times the value p. What's interestingly enough, P is actually equal to 1 over 4a. So we can go from one to the other using the same form. And for this here, knowing these general forms and having them memorized is not important. But knowing what goes where is very helpful for these here. Because we have two equations. One of them is our y is equal to a times x minus h squared plus k. The vertex for this here is the point h comma k. The axis of symmetry, x is equal to h. And we've had this before. Axis of symmetry, x equals h. Our equation here. Now something that's new, a new piece of information, is the focus. Focus is our point, h comma k plus p. And the other new piece of information is our directrix. Is given to us by the equation y is equal to k minus p. Because we do have this written here. One thing you'll definitely need to add is p is equal to 1 over 4a, a is equal to 1 over 4p. Now we've had that equation, the focus and directrix are new. The focus, the point for the focus is always going to be inside the parabola, and the directrix is the line underneath it. The directrix and the axis of symmetry are always perpendicular to each other. Now the other equation is completely new. We have not talked about this one yet. Our other equation, x is equal to a times y minus k squared plus h. Our vertex is still the point h comma k. Axis of symmetry. The axis of symmetry is a little different. Not x equals h, it is y is equal to k. That's why we have to write out the axis of symmetry as x equals. Focus is the point h plus p comma k. And our directrix, x is equal to h minus p. A is equal to 1 over 4p, p is equal to 1 over 4a. Now, I would agree, yes, it seems like there's a lot of information up here, but it's not going to be as bad as what you might think. Because again, we're going to keep referring back to these general forms and what we have to get what we need. As long as y'all stick with those general forms, matching it up, what is h, what is k, what is a, it's going to make these nice. Okay? Now, one other thing before we move on. Our y equals, there are going to be ways that we identify each. Y equals is going to open up or down. We see the sides of the parabola for y equals, especially in the graphs. Both of them are either pointing up or pointing down. The x equals, the one below it, the two arrows are either pointing to the left or to the right. X is left and right, y is up and down. Okay? The other way we can tell is the vertex and the focus, and we'll dig into that a little bit more when we get to it. But if we look at this graph here, is it opening up and down, or left and right? Left and right. We're open to the left or to the right. For the ones we're looking at, they're not going to do both. It's going to be left or right or up and down, up or down, one or the other. So here, we're opening to the right, yes? So the one that opens left or right is our x equals. All right, let's write the general form. X is equal to a times y minus k squared plus h. Open left, right, so that's what we're using. Questions on this so far? Now, according to this form, the vertex, and I'll move here in a second, is h comma k. Axis of symmetry. Y equals k. Focus, h plus p, comma k. And lastly, directrix, x is equal to h minus p. Again, all this, I just got it from the general form. Since we know that we're dealing with x equals vertex, h comma k. Axis of symmetry, y equals k. Focus, h plus p comma k. Directrix, x equals h minus p. I'm just copying it down. This is the general form. This is the information we have. Questions on this here? We understand where we got this from, yes? Now in the graph, did they tell us the axis of symmetry of the directrix? No. Do we really need it? No. At this point for these first few, I'm going to keep listening because this is part of it. We're not going to need it. We're not going to need to find it. But it is part of this equation. These are the characteristics of it. We won't use it, but these are here. Does that make sense? Because again, we're wanting to connect the general form to the information we have. Now they did tell us the vertex. Well, they came over to here, well, they're going by 2, so the x value of the vertex is 6. The y value is 2. So the vertex, even though they didn't give us the point, they did give us the graph, is 6, 2. The focus, over 2 more, is 10, 2. Questions on this so far? Well, let's compare it back. They gave us the vertex, 6, 2. Focus, 10, 2. Okay. We good with this here so far? Yeah. Okay. Now this is the equation, x equals a times y minus k squared plus h. There's 3 values I need. I need a, h, and k, yes? I need to find a, I need to find h, and k. I already have 2 of the 3. Vertex is what? H comma k, yes? Our vertex is 6 comma 2. So what is h? 6. What is k? Well, that's nice, isn't it? Because if we look at the equation, x equals, I don't know a yet, but I know k is 2. I know h is 6. I can plug those in. We're almost done. I get a and I have the equation. But that's the nice thing with the vertex. The vertex gives us h and k. We have that. So now all I'm missing is a. A is 1 over 4p. So I need the value of p. Well, let's look at the other piece of information they gave us. Focus is h plus p comma k. Well, k is 2. We already knew that from the vertex, yes? But h plus p is taking the place of 10, yes? So I know that h plus p should equal 10, yes? Do we know h? Do I know what the value of h is? 6. So 6 plus p is equal to 10. We just need to first solve for the value of p. We can do that by what? Subtracting 6. So p is equal to 4. Now in years past, at this point, we would have plugged this value p into the equation 1 over 4p times this here. Might as well just do 1 over 4p on the side and then plug it back in. So we're saying 1 over 4 times 4. Again, you can do this by hand, you can do it in the calculator. 1 over 4 times 4 is 116. That's A, yes? It also says P is 1 over 4 times A, yes? Times. This seems odd, isn't it? I can just plug it back into the same formula and somehow get back to what? 4, because 4 was A, yes? P is A. P is 4. A is 1/16. They work nicely this way. So, A is not what I wanted. Replace A with we can say, would it be wrong for me to say that this is a lot and not a lot all at the same time? It's complicated but not complicated. It's weird how it works that way, yes? But again, as long as we are connecting these back to these general forms, what's A, what's H, what's K, and plugging them in, this works out nicely. And again, I am not expecting you to memorize these forms. Even on the test, you can write them on your review sheet. I highly suggest you write them on your review sheet and keep referring back to them. Keep matching these back up because it makes these nicer to work with. And I will tell you right now, it is very easy to flip these to get your focus, the H plus P comma K and K, or so H plus P comma K and H comma K plus P, getting those flipped. It's very easy to do it. If, again, as you saw at the start when I wrote those on the whiteboard, I had a note sheet in hand. I was literally just copying it because even for me, it's still easy to get these flipped. So, again, we're just keep referring back to these here. We're going to look at another one. So we look at this one here. We open it up, down, or left, right? Left, right. So our general form, x is equal to a times y minus k squared plus h. So I'm going to be nice to you here. What is the information they gave us? They gave us what? They gave us the vertex and the focus, yes? So in the general form, the vertex is h comma k. The focus is what? H plus p comma k. Those are the two main pieces of information they gave us. They didn't give us the directrix, x equals h minus p, or the axis of symmetry, y equals k. If we are given the directrix or the axis of symmetry, it does make it easier to pick which one it is, because the two directrix are either what? X equals or y equals. It's easy to pick which one it is, because if it's x equals, oh, it's our x equals equation. If the directrix is y equals, there's only one with y equals, it's our y equals. We just matched that up. Y'all see that there. Now this is nice because it gave us the graph, yes? Now the vertex is over here at the point -2, 4. The focus is at the point 2, 4. Say we didn't get the graph. We're given the 2 points, vertex and focus, negative 2, 4, 2, 4. Did the x or y change? From negative 2, 4 to 2, 4. The x has changed from 2 to negative 2, yes? I'm going to go back to this here. If we look at y equals, so I didn't write it, but I'm going to write it, vertex. From here to here, h to h, does the x value change? No, if the x value doesn't change, it means I'm looking at y equals, because the vertex, I have k, here I have k plus p. Doesn't matter what p is, that number is going to change. Do we see that there? And we'll see some more examples where we have this. But our x equals vertex is still going to be h comma p. Here, we're going from k to k, but we're going from h plus p to k. So if we're just given the points, the vertex and focus, we're looking at which one changed, which one did we add a value to. Doesn't necessarily mean it increased, it just means it changed. Because p could be positive or negative. So if we're just given the points, we're seeing which one changed. And for us here, negative 2, 2, the x value changed. We went from h to h plus p, it changed. So that means we're looking at x equals. Do we see that there? And again, matching up a, h, and k. Those are our values that we want. And it'll make more sense because here we have the nice picture, so we can see it there. Vertex, negative 2, 4. Focus, two, 4. So from vertex to focus, we went from negative 2 to 2. It changed. So the focus has to have that plus p with the h, not the k. We need to find a, h, and k. H and k, what are h and k? Negative 2 and 4. H is negative 2, k is 4. That's kind of nice. X is equal to a times y minus what? What goes inside the parenthesis here? 4.
Oh, yeah.
Y minus k. Because again, we just got to be paying attention to that because in the general form, so x equals a times y minus k squared plus h plus negative 2. Do we normally write it as plus negative 2? We say what? Minus 2. We can say y minus 4 squared minus 2. Same thing's true inside. We don't say minus negative 2. We say plus 2. Now the only thing we're missing is what? A. And to find A, we need to find P. Our P is in the focus. H plus P is equal to what? 2. Because that's what they tell us. So the focus is 2, 4. H plus P is 2. But what is H? Negative 2. So we're saying the negative 2 plus P is equal to 2. What can we do to get P by itself? We can. Add how much? Okay. Questions? Negative 2 plus 2 is 0. 2 plus 2 is 4. So our value P is 4. Now we don't plug that in because that's not A. A is 1 over 4 P. So we'd have 1 over 4 times 4, which we actually just found a minute ago, is they're not always going to be that. They just worked out the last two worked out that way. And it's going to work out that A is not always going to be a fraction. We can actually have a as a whole number. But that's it. Questions on this so far? We ready for the next one? Okay. Left, right, or up and down? Up or down? So that means our general equation is what is equal to.
I have your attention, please. It's now time to release the softball girls. It's now time to release the softball girls. Thank you.
Good luck. If y'all have questions, let me know. Now they gave us the vertex and the focus. Now the focus is actually that point right there. It's yeah, 1.25. It gave it to us. So I made some of these here so that we have the graph for them so we can relate the two together. Now, the vertex in the general form for y equals is the point h comma k. I'm going to go and list all of them for this here. The axis of symmetry, x equals h. Our focus is the point h comma k plus p. And our directrix is the equation y equals k minus p. Now for this one here, just like the first one, did they give us the directrix or the axis of symmetry? Well, no, so we don't need either one of those. But just like the last two, we still need to find the values of a, h, and k. We find those three, we have our equation. Now it told us the vertex is the point 1, 0. It told us the focus is the point 1, comma 0.25. So what's our value of h and k? 1 and 0. So we plug those in. Y equals a times x minus h plus k. So again, since it's x equals, h is now inside the parentheses, k is outside. When it's y is equal to it, k is inside, h is outside. That is one thing I would say it's good to write the general form so we make sure we're keeping h in the right spot, k in the right spot. Probably the other question you look is, do we really write plus 0? No, we don't need the plus 0 because, again, it's not adding anything to it. I wrote it here just so we see it. So if it's plus 0, we don't need it. If it's plus 0 or minus 0, we don't need it there. Now, the only other thing we need to find is what? A, but to find A, we need P. K plus P is equal to 0.25. Solving for P in this one is actually very nice. Because what's our value of K? So we're saying 0 plus P is 0.25. So P is 0.25. That's why I said it's kind of nice. It just solved itself pretty much. But we still need to find the value of A. A is equal to 1 over 4 times P. A is equal to 1 over 4 times 0.25. Again, at this point, we can plug it in the calculator and let it do it for us. We can do it by hand. This one's actually nice. What's 4 times 0.25? 1. So it's really saying that I have 1 over 1, which is 1. So we can plug A in. Do we actually do 1 times or write that out normally? 1 times instead of parentheses? Well, no. Instead of 1 times our x minus 1 squared, we can just say x minus 1 squared. We don't normally add the plus 0. So that's it for that equation. It's just x minus 1 squared. Everything else simplified out, it's understood. Questions on this here? We're ready for the next one. All right. You don't have to draw this. I'm going to draw this in. Let's give the color something purple. Purple sounds good. Let's try that again. There we go. There is a line that does exist between the focus. You don't have to draw that in. I wouldn't draw it in because this is additional information. But there is a line that we can define that does this here and has a special property that the distance from the parabola to that point and from the point to the other side actually has the same distance. Okay, big deal. That's fine. And they give it a special name. They call this length here the length of the lattice rectum. No, that's fine. That's, again, I find that kind of humorous why they named it that way. And again, pointing this out, because last year I had to point out that this is kind of humorous, but this will be the 10th year teaching. This is the second year I've actually gotten some chuckles out of that name. Because it is, I mean, that is humorous why they would call it the length of the lattice rectum. But 8 years, it's pretty much been yes. Okay. All right. But it's part of a parabola. Don't know why, but that's why they called it. So that's what it is. But let's look at this here. Now, if we look at the vertex in focus, let's ignore the graph for now. Vertex is 4, 2. Focus is 4, 11 fourths. Does it change? Do the x's, the x value, the first value, change from the vertex to the focus? No. The y value, the second value, goes from 2 to 11 fourths. So if I look back at the general form, first one here, the first value, h and h, stays the same. So that means our equation is y equals. If it didn't, here, h to h plus p. Doesn't matter what it is, but it is changing. We're adding something to it. It could be positive or negative. So if we look at this here, well, now if we look at the graph, it is indeed going up and down. So this is our y equals a times x minus h squared plus k. So we don't necessarily need the graph. We're looking, what is the information they gave us? How is it connecting? How is it working together? In the general form, the vertex is still the point. h comma k. And they gave us the focus, which is h comma k plus p. And again, we're needing the values of a, h, and k. Well, they told us the vertex is 4, 2. The focus is 4, comma 11 course. So just looking at the vertex, it tells us the value of h is what? And the value of k is 2. The vertex is always going to be h comma k. H is going to come first, k is going to come second. General form where h and k are depends on which one we're looking at. So y is equal to a, we don't have it yet, parentheses, x minus h. That's x minus 4 squared plus 2. We're almost there. We just need the value of a, but to find a, we need p. But the general form told us that k plus p is 11/4. And luckily, we do know what k is. K is 2. So 2 plus whatever p is gives us 11/4. Most likely, p is going to be a fraction. And to find p, we would subtract 2. Minus 2 is indeed 3/4. But in order to finish this up, we do need to find the value of a. And again, 1/4 times 3/4. We can plug that into the calculator, let it do it for us. And it tells us it's 1/3. So y equals 1/3 times x minus 4 squared plus 2. Questions on this here? Interestingly enough, we could have done the 1/4 times 3/4 in the calculator. 4 times 3/4, the 4 and the 4 in the bottom would simplify, leaving us with 3, 1/3. Questions on this here? You don't have to do it by hand, you can do it in the calculator. Let it do the work for you. Questions on this here? We ready for the next one? Because we're in 7th period, right? Yeah. Let's at least, I want to start it. We may not get to finish it, but I do want to start this. Now, the one that I have written up here is missing the y equals. Yours has it already written in. I think I just keep forgetting to add that in each year. So negative 27/2 y equals is our directrix, yes? They didn't give us a graph, so it's kind of hard to tell up, down, left, right, yes? It would be up and down. Now, if we look again, as I've said so far, we keep referring back to the general form each and every time, yes? So I'm going to come back to this here. I saw that there. If I look at x equals, its directrix is what? X equals h minus p, yes? Is that what we have? Well, no, we don't have x equals, we have what? In the other form, the directrix is y equals k minus p. I don't know k and p yet, but it has y equals, yes? So that's the nice thing with the directrix, because if we have x equals for the directrix, it's our x equals equation. If the direct is y equals, it's our y equals equation. We can just look and see which one does it match up to. Which means the general form for this here is y equals a times x minus h squared plus k. We still need to find the value of a, h, and k. We get these three values, and we have our equation. Vertex in the general form is h comma k. Our directrix, y equals k minus p. The point vertex for this here is 5, negative 1. So h is 5, k is so we'd have x minus squared plus negative 1. Well, we don't have to write plus negative 1. We can just write what? Okay. So we can just write minus 1. Questions on this here? So what are we missing? A. A. So to find A, we need P. That's where the directrix comes in. So this is a little different than the previous ones, because now the K minus P for directrix is lining up with the, well, again, we're just lining these up to the general form. We keep matching them up. Now, solving the rest of this is going to be similar to what we've done. We know what K is. K is negative 1 minus P is equal to negative 27 over 2. So the first thing I can do is add 1. Negative 27 over 2 plus 1 is negative 25 over 2. Don't really care too much about what negative P is. We want to know what positive P is. So there's two ways we can get about this. One is that we can multiply both sides by negative 1. The other is that we divide both sides by negative 1. Either way you do this, you will get to the same answer. Because if I multiply this by negative 1, it gives us 25 halves. And lastly, to find A, we do 1 over 4 times P. 1 over 4 times 25 halves is over 50. And that's where we're going to stop.